Energoinvest was established in 1951 in a socialist Yugoslavia in which at the time the fanatical faith in heavy industry was preached. At the time when the ruling Marxist ideology declared the collective work of the working class as the main factor of historical progress, establishment of a company relying on knowledge seemed almost like a political diversion. However, Energoinvest was a product of a vision of an authentic business genius. That man of bright memory, engineer Emmerich Bloom, knew that the business of New Age will be based on the power of the mind and moral values of the people. Led by the pioneer spirit, Energoinvest grew quickly in all dimensions and qualities. Based on own projects, factories were built one by one, used for production of reinforcement structures, power pylons, tons of grey cast. As early as 1959, Energoinvest crossed the borders of the country and entered the international market. The expansion continued through reliance on own factories for production of electrical equipment for low, medium and high voltage. In parallel, factories were built for production of processing equipment, heating equipment, heat converters, containers for non-standard pressures and temperatures of water and steam, and specialized reinforcements. At the same time, capacities were built for production of equipment for transfer of electric power. It was in this specific domain, design, production and construction of the largest pylons with transformers, that Energoinvest earned a respectable international reputation. Energoinvest reached a high international rating also in the sphere of design and production of systems for automated management of production processes in hydroelectric and thermal power plants, oil pipelines, facilities in air and sea traffic. Energoinvest designed and built more than 60,000 pylons of different voltage levels worldwide, and around 7,000 transformers, of which 500 fall into the category of the largest power facilities. Energoinvest constructors built more than 50 hydroelectric power plants in the country and worldwide. For example, Jajce 1 and 2, Jablanica, Salakovac, Trebišnica, Rama, Visegrad, Bochac. Energoinvest's name is printed on more than 30 thermal power plants in Kakaň, Tuzla, Gacko, Ukljevic, Kosovo, Novi Sad, Subotica, and Kalokot and Kanpur in India, Palembang and Medan in Indonesia. Energoinvest also built production capacities of high industrial complexity, such as aluminium in Mostar, aluminum oxide factory Birac in Zvornik, aluminum processing factory in Šipovo, Vlasenica, Bihać and Široki Brijeg. Energoinvest put its signatures also on refineries in Bosanski Brod and Modrica, Hempro in Gradačac, methanol acetic complex in Kikinda, expanded refinery in Tobruk, facilities in the Skikda refinery in Algeria, numerous liquid fuel terminals, spherical tanks in the chemical industry, and other products in the highest class of Lloyd. By designing and producing steam separators for nuclear power plants in the late 70s of the last century, Energoinvest became a member of the world's elite industrial class. Countries in other continents would lag behind achievements of the modern world. Over the past 55 years, Energoinvest was active in global development fronts. Destiny. Highly qualified experts with multidisciplinary knowledge were declared by Energoinvest from day one as the main resource, the supporting column, and at the same time as one of the goals of its development. Such orientation of Energoinvest was the industrial renaissance of the whole Bosnia-Herzegovina and the flywheel of development of university education are previously won and new competency recognitions expressed through Lloyd's Register, seals of the American Petroleum Institute, USMA Code, Stamp U and U2, Charter for the Best Achievement in Construction, membership in SIGRA, recognition of the World Economic Forum as one of the most successful companies in Central and Eastern Europe, ISO certificates of the Lloyd's Register, ISO certificates 9001-2000 and ISO 14001-2004, and OHSAS 18001-1999. Among others, Dutch and American companies bought licenses from Energoinvest. Energoinvest gave society the most respected university professors, ambassadors, mayors, ministers, prime ministers. Today, Energoinvest is a company with strongly expressed functions of engineering systems, offering synergies using the turnkey formula and servicing highly demanding local and international partners in construction, reconstruction, modernization and revitalization of complex buildings and facilities in its field of activity. Energoinvest is currently working on implementation of the Big River project in Libya, the most grandiose engineering undertaking today, thanks to which, from the Heath of Sahara using free-flow potable water, will be brought to traditional thirsty areas of Libya, including the cities on the Mediterranean coast. In the fields of increasingly competitive, innovating and profitable business in a globalized world.
Energoinvest, 58 years of tradition and confidence. Energoinvest is a leading company in Bosnia and Herzegovina in a domain of designing and implementation of complex projects in both national and foreign markets. With its wide scope of activities, Energoinvest is known worldwide as a multidisciplinary engineering company which employs 900 employees. Energoinvest's capability for successful implementation of projects on a turnkey principle provides impressive international reputation. In March 2007, Energoinvest concluded a contract with Elektroprivreda of Serbia for realization of the project ash disposal system of thermal power plant Nikola Tesla B, which represents the first ecological project of this kind in Southeast Europe. The project, at a first phase valued at 28 million euros, was financed by the European Union, the European Agency for Reconstruction. Thermal power plant Nikola Tesla B is a power plant with two units, 620 megawatts each, and it is situated in Obrenovac in vicinity of Belgrade. This thermal power plant represents the strongest support to electric power system of Serbia because it produces over 10 billion kilowatt-hours of electric power annually. The thermal power plant is fueled by lignite from a neighboring mine Kolubara, from which coal is transported by railroad. Daily coal consumption varies from 70,000 to 90,000 tons per unit. Thermal power plants represent the basis for economic and business development of a society, but unfortunately also are the major ecological polluters. Fly ash and bottom ash are accompanying byproducts that remain after coal combustion in thermal power plants. The quantity of fly ash produced by one unit of this thermal power plant is up to 240 tons per hour and up to 16 tons an hour of bottom ash. Our team of experts ended up with a big challenge in this project. We should solve the way of transportation and disposal of fly ash and bottom ash with a minimal water consumption and minimal level of pollution, which satisfies all European standards of preservation and protection of nature. Previously used system of fly ash and bottom ash disposal on disposal sites involved mixing of 17 liters of water with 1 kilo of fly ash and bottom ash, so-called low-density slurry. Huge quantities of water from Sava River were used for this way of mixing and transportation. After draining, these huge quantities of water were returned to Sava River, thus polluting underground water on its path. After water draining, the fly ash that remains in mealy condition can be dispersed even by the weakest wind over nearby settlements, and even to Belgrade. We replaced the old system of low-density slurry disposal with a new hydraulic transportation system of high-density slurry. At present, the mixing ratio between fly ash and water is 1:1. In order to provide conditions for creation and transport of homogeneous slurry at ratio 1:1, we designed and built 2 new fly ash silos, 1 bottom ash silo and 3 mixing units. After the coal combustion, the fly ash is taken from the following 3 points: from the fly ash collector of flue gas duct, from the fly ash collector of air heaters, and from the fly ash collector of electrostatic precipitators. Collected fly ash is transported by pneumatic transportation to a fly ash silos. In order to secure the operation of pneumatic transportation and control air system, we designed and built a compressor station, which is equipped with modern units for production of compressed air. Compressed air, as a key element of pneumatic fly ash transportation, is directed through the purposefully built system of compressed air pipelines. The continuous power supply of the new ash disposal system is provided by a substantion 6.6 by 0.4 kV, which is designed and built for that purpose. The pipeline system for pneumatic fly ash transportation from electrostatic precipitators to silos is placed on the new leaning bridge with the total length of 550 meters. After the coil combustion, the bottom ash from boilers is transported to bottom ash silo by the new system of belt conveyors. The grandiose leaning bridge connects the thermal power plant and silos complex and represents the basic pairing element of bottom ash belt conveyor systems and pneumatic fly ash transportation system. Within the fly ash silos complex, we designed and installed 3 mixing units, which provide homogeneous mixture of fly ash, bottom ash and water. 2 mixing units are placed below fly ash silos with capacity of 4,200 cubic meters each, while the third unit is placed in the area between 2 silos. We used the technology of fly ash removal from a silo in such a manner that any of the mixing units can be filled from both silos. Advantage of this method is that in the case the fly ash silo that is currently being emptied runs out of fly ash, the emptying of the second silo will be continued towards the same mixing unit without interruption of the process. The bottom ash silo provides continuous bottom ash supply for all mixing units. In the silos complex, we designed and installed 4 slurry pumps connected in a row for each mixing unit, thus providing sufficient power for transport of slurry through the long-distance slurry pipeline to the disposal site. The long-distance slurry pipeline consists of 3 pipes with total length of 12.9 kilometers, while the discharge of a slurry on the disposal site is provided through a 7.7 kilometer long distributive pipeline. Operation and synchronization control of the whole ash disposal system is performed by a digital automatic PLC technology. PLC, which stands for Programming Logical Controller, provides control of all elements of the system from one place. The new transportation and ash disposal technology reduced the possible level of influence of the ash disposal into the air and underground water pollution to the minimum, since the disposed content is compact and wind dispersion of fly ash particles is therefore prevented. This ecological ash disposal system provides for the use of fly ash and bottom ash in civil engineering industry so that part of the waste becomes useful. Through implementation of this project, which is the largest ecological project in Southeast Europe, we responded once more successfully to the energy development challenge of the region, with the primary goal of preservation and protection of human environment. Energoinvest, your reliable partner in ecological energy development.